Now, next rules for writing resonance. In last lecture, rules for writing resonance. In last lecture, we finish the resonance, its type, and conditions for types of resonance. इथपर्यंत आपण संपवलेलं आहे. आणि next rules for writing of resonance. Next bit rules for writing the resonance. Writing the resonance. Writing the resonance. Resonance structures. Resonance structures. Now, how write the resonance structures? First rule: resonance form exist. Resonance forms exist only on paper. Only on paper. That is they have no real existence. No real existence. The different resonance structures. The different resonance structures. The different resonance structures. Resonance structures. Structures are interconvertible. Are interconvertible. Convertible and shown by double-headed arrow. And shown by a double-headed arrow. Double-headed arrow. This is first condition, like this. Benzene interconvertible into second form. One and like this is the first condition. Resonance form exists only on paper, that is they have no real existence, and the different resonance structures are interconvertible. म्हणजे structure 1 is converted into structure 2. This is the structure 1 of benzene. When double bond delocalized, we get the structure number 2. हे पहा आपल्याला इथं काय भेटलेलं आहे? Structure number 2, and the resonance is shown by a double-headed arrow. इथं आपण हे दाखवलंय पहा. This is the symbol for resonance. म्हणजे resonance दाखवताना कुठला arrow यूज करायचं? Use double-headed arrow. This is the symbol resonance चा double-headed arrow. दो एक लाईन काढायची, दोन्हीकडे हेड दाखवायचे. This is the first condition किंवा rules for writing resonance. Rules है, पहला rule है. Resonance form exist only on a paper, that is they have no real existence. म्हणजे याच्यामध्ये no real existence ह्या फॉर्मला. The resonance structures are interconvertible and shown by a double-headed arrow. This is first rule. पहिला रूल लक्षात आला. म्हणजे resonance हा हायपोथेटिकल फिनॉमिना आहे, तो ऍक्च्युअल मध्ये पॉसिबल नाही. आणि सिम्बॉल काय? डबल हेडेड एरो. The second condition for the resonance, rule number 2, all atoms taking part, all atoms taking part in resonance, आवाज म्यूट करा, कोणाचा आवाज चालू आहे तो. In resonance, which are involved प्रिया तोत्रे, कोण आहे, आवाज म्यूट कर तुझा. Involved in the delocalization of electrons must lie in the same plane, in the same plane. Rule number 3, all resonance structures should have all resonance structures should have the same number of unpaired electrons This is rule 3. Rule second का है, all atoms taking part in resonance which are involved in the delocalization of electron must lie in the same plane. म्हणजे सर्व इलेक्ट्रॉन कसे पाहिजेत, एकाच प्लेन मध्ये पाहिजेत. If they are conjugated but out of the plane, at that time resonance is not possible. अशा वेळेस resonance होणार जर इलेक्ट्रॉन ह्या प्लेनच्या बाहेर असतील due to steric hindrance, at that time the resonance is not possible. This is the rule number 2. First rule, this is exist only on paper, no real existence. In the resonance structures are interconvertible and shown by a double-headed arrow. हा काय double-headed arrow ने दाखवलेला आहे. Rule number 2 काय, all atoms taking part in resonance which are involved in the delocalization of electron must lie in the same plane. जे काय taking part resonance मध्ये भाग घेतलेले आहेत, they should lie in the same plane. And जर out of plane असतील, planarity loss झाली तर resonance is not possible. This is rule number 2. म्हणजे इलेक्ट्रॉन एकाच प्लेन मध्ये पाहिजे आणि out of plane or planarity is lost, the resonance phenomena is not possible. Rule number 3, all resonance structures should have the same number of unpaired electrons. आणि ह्या सगळ्यामध्ये काय, same number of unpaired electrons पाहिजे. For example, CH2 double bond CH double bond CH2. They should have same number of unpaired electrons. We break this pi bond and we generate double bond like this. CH2 dot CH double bond CH and CH2 and CH2 dot. I can they have same number of unpaired electrons. इथे total दोन्हीकडे एक unpaired electrons या आहेत. This is the rule number 3. पहिले 3 rule लक्षात आले. Resonance form exists only on paper, that is they have no real existence. This is hypothetical phenomena. Different structures are interconvertible, shown by double-headed arrow. This is the symbol of resonance. Rule number 2, all atoms taking part in resonance which are involved in the delocalization of electron must lie in the plane. When the planarity is the most important parameter. And planarity laws resonance होणार नाही. And all resonance structures should have the same number of unpaired electrons. Here 0 unpaired electron and here 2 unpaired electrons. They are not correct. This is not correct. इथं जर 0 असले तर इथं काय पाहिजे 0च पाहिजे त्यावेळेस हे रेझोनन्स होईल. Now next rule number 4, all the forms rule number 4, all the forms must be bona fide Lewis structures, must be bona fide Lewis structures that is the carbon can never be shown with 5 bonds. With 5 bonds. The same is true for oxygen and nitrogen. This is rule number 3. म्हणजे ऑक्सिजनची व्हॅलेन्सी किती कार्बनची व्हॅलेन्सी किती पाहिजे it should remain 4. It never becomes 5. And same is true for the oxygen and nitrogen. Oxygen ची किती आहे 2 आणि नायट्रोजन ची किती आहे 3. For example, here we draw the structures of ethanol, methanol, CH3, OH, and here lone pair. If this lone pair is take part here resonance, this is the sigma bond, and we draw the structure CH3 double bond O the oxygen H. इथे कार्बनची व्हॅलेन्सी किती झाली 3 hydrogen 4 and 5. This is not the correct features, and oxygen valency becomes now 3 1 2 and 3. All the forms must bona fide the Lewis structures. एक आहे Lewis structure उभे केले, and carbon be never shown with 5 bonds. Carbon चे 5 bonds झाले तर काय होणार this is wrong. Or same is true for oxygen and nitrogen. Oxygen valence is 2. आएगा इधर 1 and 2, and this double bond is converted into 3. ये चुकीचं आहे. And nitrogen valence is 3 converted into 5. This is also wrong. This is rule number 4. The methyl carbon has 5 covalent bonds, which is not the possible. Rule number 4. Rule number 5. Rule number 5. In writing resonance form, in writing resonance forms, we can move only electrons, the relative positions of the atoms must remain same in all the resonance form. In all the resonance form. In all the resonance form. This is rule number 5. In writing resonance form, we can move only electrons. फक्त pi electrons shifts करायचे. The relative position of the atom must remain same in all the resonance form. Atom की position change होणार नाही. फक्त कशाची position change होईल? Carbon carbon double bond or pi electrons. For example, CH3 CH plus CH double bond CH2. CH double bond CH2. This is in conjugation with the positive charge. We shift here pi electrons and we form CH3 CH double bond CH double bond CH and CH2 plus CH2 plus. Atom की position काय त्यामध्ये सारखे आहे, but we do not change the position of pi bond. It changes. The pi bond की position change झाले पहा. Positive charge is present on carbon number 1. We look 1, 2, and 3. And now carbon positive charge is shifted on the carbon 1 and 2 and 3 carbon carbon double bond आहे का 1, 2, 3. म्हणजे बाकीच्या ॲटमची पोझिशन सारखी आहे, फक्त 2 आणि 3 ला डबल बॉन्ड आला आणि एक वरती पॉझिटिव्ह चार्ज. That means we shift or mobilize only pi electrons and the position of atoms remains same. For example, we draw this. This is the same structure. If like this CH2 H CH positive charge CH double bond CH2 double bond CH2. We break this sigma bond between carbon and hydrogen and we form bond CH2CH. At that time, the position of carbon is changed. Position of atom is relatively changed. Like CH2 double bond CH single bond CH double bond CH2 double bond CH2. This is not the correct in resonance. आहे का? ह्याच्यात काय झालं? We add the extra bond किंवा एक हायड्रोजन कमी झाला म्हणजे atom ची positions change झाली. This is not happen in the resonance. Here only electrons should move. इथे फक्त electrons move होतील and the relative position of the atoms must remain same in all resonance. त्यामध्ये सेम आहे का resonance form मध्ये? 1 मध्ये काय CH3 आहे and 2 मध्ये काय झाला शेवटचा CH2. This is not the same. Therefore, this is not correct. writing of the resonance. 1 and 2 resonance forms, but 3 is not writing because position of hydrogen atom is changed. This is about the rule number 5. हा काय rule number 5 आहे. In writing resonance form, we can move only electrons. कुठले इलेक्ट्रॉन मूव्ह करायचे? Only pi electrons. Sigma electron ला हात लावायचा नाही. And the relative position of the atoms must remain same in all the resonance form. आणि बाकीच्या atoms काय position सारखी पाहिजे resonance form मध्ये. This is rule number 5. And rule number 4 काय? All the atom must be bona fide Lewis structure. That is, the carbon can never be shown with a 5 bond, and same is true for oxygen and nitrogen. Then rule number 6. Rule number 6. Rule number 6. Rule number 6. If more the number of equivalent resonance, if more the number of equivalent resonance structure, more is the stability of the resonance hybrid, of the resonance hybrid. This is rule number 6. If more the number of equivalent resonance structure, more is the stability of the molecule. When we draw a resonance hybrid for this structure, this is 1. Here, this pi electron is shifted here, and this pi electron is shifted here. This is first resonating structure of benzene. Double bond, and double bond. This is the first, and this is second. First and second. And we draw third is the resonance hybrid. This is the dot, and dot, looking like this. This is the third resonance hybrid. Third resonance hybrid. That means structure and 1 and 2 are the equivalent structures. Their contribution to the hybrid third, and any other resonating form. म्हणजे जास्त structure equivalent structure असतील तर त्याच्यासाठी काय करायचं आपण? Resonance hybrid structure we should draw. This is rule number 6. Rule number 7. Rule number 7. Structures which involve charge separation. Structures which involve charge separation. Structures which involve charge separation makes less contribution to the resonance hybrid, then those structures which do not which do not involve charge separation. Involve charge separation. Involve charge separation. Structures which involve charge separation makes less contribution to the resonance hybrid than those structures which do not have involve or charge separation. म्हणजे ज्या स्ट्रक्चर मध्ये जास्त चार्ज सेपरेशन आहे ते रेझोनन्स हायब्रिड मध्ये भाग घेत नाहीत आणि ज्याच्यात कमी आहे they should take part in the resonance hybrid structures. For example, CH2 double bond CH double bond CH2 double bond CH2 CH2 plus CH2 plus CH double bond CH2 minus CH2 minus. This is the charge separation. Second, this is first structure. This is the second structure. Now third structure, CH2 minus CH double bond CH2 CH double bond CH2 CH double bond CH CH2 plus CH2 plus. And structure number 4, CH2 plus CH2 plus CH minus CH double bond CH2 CH double bond CH2. Third and fourth. This is the resonating structure, third and fourth. Structures which involve charge separation takes less contribution to the resonance hybrid than those structures which do not involve charge separation. आता याच्यामध्ये structure second, third, fourth less stable. Structure म्हणजे 2, 3 आणि 4 हे काय less stable structures due to they involve the charge separation आहे का positive charge, negative positive and positive negative, and the structure first is more stable as it does not involve any charge separation. Structure 1 मध्ये काय आहे का कुठले charge neutral molecules and its contribution to the resonance hybrid is more आणि म्हणजे हे more contribution कुठला असेल structure 1. So this is rule number 7. लक्षात आला ज्या स्ट्रक्चर्स मध्ये चार्ज इन्व्हॉल्व झाले ते स्ट्रक्चर्स काय लेस स्टेबल आहेत दॅन द स्ट्रक्चर्स विच डू नॉट हॅव द चार्ज सेपरेशन किंवा त्याच्यात चार्ज जनरेट झाले नाही और न्यूट्रल मॉलिक्युल्स विच हॅव मोर कॉन्ट्रीब्युशन टू द रेझोनन्स हायब्रिड. हा पॉइंट लक्षात ठेवा. चार्ज सेपरेशन असेल तर लेस कॉन्ट्रीब्युशन अँड लेस स्टेबल, नो चार्ज contributions more stable and more contribution in the resonance hybrid. This is condition number 7. Condition number 8. Condition number 8. Condition number 8. Those structures in which those structures in which negative charge is present on more electronegative element are more stable those structure in which negative charge is present on more electronegative element are more stable. For example, CH2 minus C double bond OH acetaldehyde, C double bond OH. The negative in first structure, the negative charge is present on carbon, which is less electronegative than the oxygen, and we draw second resonating structure CH2 double bond CHO minus. The negative charge is now present on more negative atom, electronegative atom, that is oxygen, is more stable. That means structure 2 is more stable than structure 1. Structure 2 is more stable than structure 1. Why? The negative charge is present on more electronegative atom, that is the oxygen. This is rule number 8. Rule number 8 मध्ये काय? Those structure in which negative charge is present on more electronegative element are more stable. Now, last rule, rule number 9. Rule number 9. Structures which contain distorted bond angles and bond lengths are less possible. And bond lengths are less possible, are less stable. Last condition का है? Structures which contain distorted bond angles and bond lengths are less stable. म्हणजे जिथं bond length आणि bond angle distort झालेला आहे, these structures are the less stable. And for example, we draw benzene structures. One, 2, 3, 4, 5, and 6. And we draw its resonating structure with distorted bond angle and bond length. Here at 1 and 4 position, we draw the bond. And this structure is less stable as compared to structure 1. It contains distorted bond length and bond angle. These are the rules for writing the resonating structures. They no rules side. त्या rules नुसार आपल्याला काय bond resonating structures काढायचे. First rules काय? Resonance form exists only on paper. हा paper वरचा form आहे. It is no real existence किंवा hypothetical phenomena आहे. The different resonance structures are interconvertible and shown by a double-headed arrow. रेझोनन्स स्ट्रक्चर्स हे काय एकमेकात इंटरकन्वर्ट होतात आणि त्यांचं चिन्ह काय डबल हेडेड एरो. इम्पॉर्टंट हे लक्षात ठेवा. व्हॉट इज द सिम्बॉल ऑफ रेझोनन्स? इट्स सिम्बॉल इज डबल हेडेड एरो. हा पहिला रूल झाला. रूल नंबर सेकंड काय ऑल atoms taking part in resonance which are involved in delocalization of electron must lie in the same plane. म्हणजे प्लेनॅरिटी हा मोस्ट इम्पॉर्टंट पॅरामीटर आहे. आणि प्लेनॅरिटी लॉस्ट झाली तर काय होणार रेझोनन्स फिनॉमिना पॉसिबल होणार नाही. म्हणजे सेकंड फॅक्टर मध्ये काय वी शुड मेंटेन द प्लेनॅरिटी ऑफ द मॉलिक्यूल. ऑल pi electron should present in one plane. हे जे काही pi electrons आहेत ते काय पाहिजेत एका प्लेन मध्ये प्रेझेंट पाहिजे. दिस इज रूल नंबर 2. ऑल रेझोनन्स स्ट्रक्चर शुड हॅव सेम नंबर ऑफ अनपेअर्ड इलेक्ट्रॉन्स. म्हणजे आपण जे पहिल्या स्ट्रक्चर मध्ये जेवढे अनपेअर्ड इलेक्ट्रॉन आहेत त्या पुढच्या स्ट्रक्चर मध्ये सुद्धा तेवढेच अनपेअर्ड इलेक्ट्रॉन. अनपेअर्ड इलेक्ट्रॉन चेंज झाले तर दिस इज नॉट द रेझोनेटिंग फॉर्म. दिस रूल नंबर 3. ऑल फॉर्म मस्ट बी बोनाफाईड लिव्हिज स्ट्रक्चर्स. हे सगळे स्ट्रक्चर कशा पाहिजे लिव्हिज स्ट्रक्चर मध्ये. कार्बन नेव्हर शोन विथ 5 बॉन्ड्स म्हणजे कार्बनचे 5 बॉन्ड दाखवायचे नाही. ट्रू फॉर ऑक्सिजन अँड नायट्रोजन. आणि ऑक्सिजनला 3 आणि नायट्रोजनला 4-5 असे बॉन्ड. These are not the features. In writing resonance forms, we move only pi electrons. ज्यावेळेस आपण रेझोनन्स फॉर्म काढू त्यावेळेस कुठले इलेक्ट्रॉन व्हायला मूव्ह होतील pi electron, and the relative position of atoms must remain same in all the resonance form. आणि atom ची पोझिशन काय सारखी राहील. atom ची पोझिशन चेंज होणार नाही. Only the position of pi electron should be changed. Next, if more number of equivalent structure, more is the stability of resonance hybrid. जर जास्त इक्विव्हॅलेंट स्ट्रक्चर असतील तर काय त्याची मोर स्टेबल मॉलिक्युल्स असेल तो. Structures which involve charge separation make less contribution to resonance hybrid than those structures which do not involve charge separation. म्हणजे ज्याच्यात charge separation involved होतं they should contribute less to the resonance hybrid. And if more charge separation and these structures should be less contributed for this. And structures second, third, fourth are less stable to separation of charges. And आपण example दिलेलं आहे ते charge separation चं. Those structures in which negative charge is present on more electronegative element are more stable. म्हणजे निगेटिव्ह चार्ज कशावरती पाहिजे मोर इलेक्ट्रोनेगेटिव्ह ॲटम वरती निगेटिव्ह चार्ज पाहिजे. ॲट दॅट टाइम द स्ट्रक्चर इज मोर स्टेबल. And if the negative charge is present on less electronegative atom, at that time the structure is less stable or molecule is less stable, or this is not feature with the organic chemistry. म्हणजे निगेटिव्ह चार्ज हा कमी लेस इलेक्ट्रोनेगेटिव्ह ॲटम वरती राहणार नाही. हे फीचर्स आहे ऑर्गॅनिक केमिस्ट्रीचे. इट शुड प्रेझेंट ऑन मोर इलेक्ट्रोनेगेटिव्ह ॲटम. म्हणजे ऑक्सिजन वरती प्रेझेंट राहील, नायट्रोजन वरती राहील, फ्लोरीन वरती राहील, like this. And structures in which distorted bond angles and bond lengths are less stable. This structure should be the less stable. These are the rules for writing resonance. त्याच्यामध्ये काही प्रॉब्लेम आहे का कुणाला? रूल्स फॉर रायटिंग रेझोनन्स मध्ये काही प्रॉब्लेम आहे का कुणाला? आहे का प्रॉब्लेम?
नो सर.
ओके, मग नेक्स्ट आपण स्टार्ट करू हायपर कॉन्जुगेशन्स. Next bit, hyperconjugation. 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 It is related to sigma electron. Remember, resonance is related to pi electrons and hyperconjugation is related to the सिग्मा इलेक्ट्रॉन. दोन्ही जवळपास फिनॉमिना सारखेच आहेत. रेझोनन्स इन्व्हॉल्व डिलोकलायझेशन ऑफ पाय इलेक्ट्रॉन्स अँड हायपर कॉन्जुगेशन इन्व्हॉल्व द डिलोकलायझेशन ऑफ द सिग्मा इलेक्ट्रॉन. हायपर कॉन्जुगेशन इज मॉडिफिकेशन. हायपर कॉन्जुगेशन is modification, is a modification of resonance. Modification of resonance effect. Resonance effect म्हणजे हायपर कॉन्जुगेशन काय हा रेझोनन्सचा मॉडिफिकेशन आहे. म्हणजे आता तुम्हाला लक्षात आलं असेल, म्हणजे इट इज ऑल्सो द डिलोकलायझेशन ऑफ